So I'm just gonna wing the action items just from reviewing the previous one, and we'll fill it in. So anyways, let's go ahead and get started. So
Hey, before you start, is this meeting being recorded?
Always.
Yes.
Okay.
So it comes pre-recorded. So when the moment you hop in, it's already recording.
Excellent. Thank you.
All right. So agenda bashing. That's.
I think I've already got my stuff on the agenda. I've been working on some narrative slides to explain network service mesh, which are hopefully much clearer to folks because they sort of build things out piece by piece with less animation, and they have fun characters.
Woohoo! Okay. So as always, we have a upcoming event coming up in just over a month from now, the Cloud Native Network Function Seminar at the Open Source Summit. So again, if you are signing up for the Open Source Summit, and if you are able to make it, make sure you check the appropriate box while you are registering. And that will be in Vancouver. Okay, so we also have a special announcement. We had a small talk with among ourselves, and we've decided to add Sergey as a committer to the project. So I want to congratulate Sergey and thank you for all of the work that you've put in at this time.
Thank you.
Many congratulations. You've done a ton of work.
So, okay, so for the action items, so I see that someone's filling out items, so I will go to the bottom. If we can do this with some teamwork, that would be great. So Docker Hub images. So I recall that we had a little bit of work towards this, if I recall. Do you know what the current status is, Ed?
So we have a Docker Hub repo in Legato Network Service Mesh. All the committers for the Network Service Mesh repo should have admin privileges on that Docker Hub repo, and so that part of the road has been cleared. Now we just need to publish Docker images to that Docker Hub repo upon merge, and I think we'll be good. But there's still a little bit of work done to publish those images. It's not entirely clear to me how to make Travis run after the merge in order to do so. Maybe someone has a better notion of how that works.
Yeah, I'll take a look at that. Like if it's going into code review and it's already gone through code review, I think that should be, like, when it merges, it should be in pretty good shape. And what we may end up having to do is it may not end up being a Travis hook. It might end up being a Docker hook that watches the master branch, which is not as good as having Travis push it up, but that is an option. Another one is we could inject one of our credentials into Travis if Travis gives us the ability to do that, and if it does, then we'll make use of that and just do a Docker push directly from the script. So I think those may be our two options.
Okay, cool.
All right, so let's see. There's an action item for fixing a couple bugs in the Makefile. I believe Kyle was working on that, but he's not able to attend today. So we'll circle back to that next week. And
Kyle is off coaching his kids' baseball team today.
Woohoo! Okay, so let's see. There was some brainstorming in the mascot, and Dixuna put together a very nice list for us. So thank you for putting that together.
Welcome.
Yeah, I have tentatively, let me go ahead and stick this link in. I've tentatively started using this as a mascot-like creature. Let me find the right link to send you here. There we go. So this is, I've sort of started using Adrian, the spider, as the mascot, at least for the conversations in the narrative deck.
Is someone sharing the screen with the agenda, with the doc? I don't see it on the share. Should I share it if you're not doing it? So I can do it.
Would be very helpful. Thank you.
All right, sure. I'll do that right now if I have enough bandwidth here where I am. Just a second here. So okay. Stop one. What the hell do I? Oh, I think it's this. Okay. Hopefully it isn't the thing. And let me look at. Okay, can you see? Okay.
There's a big blank screen in the middle, but I can otherwise see.
How's that?
Much better.
Ah, yeah, because the little Zoom dialog box comes up on top, and I guess that's sort of like a tautology, you know. It has to.
You want to do a quick share of the link that I just stuck in the chat for the sort of Adrian, the network service mesh spider?
That should show up in everybody's chat, but where do you want that added to the doc?
No, just open the link so that the people can see.
Oh, I see what you mean. Yeah. Just a second here. Let me bring up the chat. How do I get the chat to more? Chat. Aha. Okay. Link. Here we go. From Ed to everyone. Ah. Cool.
So it's remarkably difficult to find a friendly spider.
Well, I live in Richmond, Virginia, and the University of Richmond uses a spider as its symbol for its sports teams. Interesting, but it's a very sort of it's not as beautiful and pretty as this spider.
Yeah, this spider looks a little bit like an Einstein, you know.
It is a thoughtful spider. It has definitely thought deep thoughts about manifolds.
Cool. So, Tom Herbert put together a PR for us, documenting the startup process, and so he's so I'm in the process of reviewing that, and we'll go ahead and work to get that in. If anyone wants to help review or run through it, that would be greatly appreciated. The link is in the network service mesh GitHub in a pull request, and let's get the pull request number right now. So the pull request is number 176. Okay, and we have an action item listed for Taylor Carpenter on pull request in Kubernetes as enhancing the write-up for the CNCF project. Taylor, I'll give you a few moments.
Yeah, so let's see, that's ticket 165. Right. Can y'all hear me all right?
Yes.
So I might be double muted. Okay, so ticket 165 is kind of where we're drafting that and working on something similar to the network service mesh use case Google Doc for the specific use case that we're talking about. Let me see. Post this in the chat. Oh, thanks, Luciana. You already did it. So the ticket 165. So this is going over the CNCF project. This is the first part. So the two main goals that we have are performance comparison between DNS and VNS. So the VMs, whether that's Cape VM directly or using something like OpenSec for the orchestration, and then Docker for containers, and then eventually what we want is the orchestration piece. So that'd be where Kubernetes ties in and where we're running else help. And the next part is the use case, which I'm trying to put some more material together. The diagrams and stuff around this use case are not too great, but probably use some of those until we create a new one, which is something we need anyways. So the VCP use case has a lot of needs from what y'all are doing in NSM that seem to be aligned with some of the existing goals, like the in the NSM use case document, the L2 traffic for CAP WAP controller, that covers some of the items that we're trying to do, like passing L2 frames across the pod. So I've added some of that in as far as what do we need if you're looking at the ticket. So what do we need there? So multiple network interface support, different types of interface. We want to be able to do PCI pass-through and other things, SRIV, vhost user, the transporting the L2 frames, like I was just saying. And then one item that I'm not sure if it may be somewhere, and I'm not saying it's as visible, but it would probably tie in with how we implement the use case, is more fine-grained control over resource utilization. So when we're bringing these up and we need a network function to be isolated with, say, one core, and this ties a little bit into the comparison, but also the use case when we're saying the density and everything else for the utilizations of these, is a core pinned to the network function in a container? Is it actually pinned there, or is it going to be shared across the node pod? Where is that? So that's not as clear to us on how that would tie in with bringing it up. And I think, so the other part would be ensuring that part of what we're doing in our initial testing, we're having to do the work outside of Kubernetes. You have to come in and run things to get stuff connected. So this is all the networking. There's also the stuff about looking at the CPU pinning or whatever you pass. So of course, using Kubernetes principles and everything else and tie it in to how you're orchestrating all of this. So the draft is there. We're still working on it, and going to keep updating on that 165 and add in where are the blockers. So that's kind of after the overview, which is pretty close. Put in some diagrams and other stuff, maybe a link to a more extensive detailed doc that we're working on. And then where are we saying we're blocked as far as Kubernetes? So I think that's the next, which I listed a few of the items. We're in the midst of doing tests right now, so we're seeing where we get blocked. So we'll be adding to that ticket, I think, and but here's real blockers and where we had to go outside. Work in progress.
Fantastic. So thank you very much for the update.
You're welcome.
And let's see, the last okay, so we also had a action item on so we have one called a multi-tenancy group on Ed, and there's not as much information on that. Ed, are you do you recall what this is? You might be on mute as well.
So in conclusion, hang on a second, let me take a look. See if I remember. Okay, so in a multi-tenancy group, I've not talked to them. A quick update on the stuff that's going on with the conversations about Kubernetes work groups. So we're trying to figure out if that's actually the right vehicle. SIG Network thinks so. There are some other folks who are asking interesting questions around that on the PR. We're going to talk to some of them and see what their thoughts are. But our overall position, I think, and I want to confirm that this is the position of the group, is probably we're looking for the right formal vehicle, and we're pretty open about what that is. Does that match everybody else's sentiment?
Yeah, I think that's a good description. Like, where's the best place that we can where we can collaborate on these and make sure that we can also get the right people.
Yeah, yeah.
Okay, so in terms of the Cloud Native Compute Foundation cluster, so we now have access to a cluster, and special thanks to CNCF for organizing that, and the group from Packet who have been fantastic, and they provide the actual hardware for the CNCF cluster. So we now have we need to add Sergey to the list of people who have access. So Sergey, after the meeting sometime, send me your email address and I'll forward it on to the right person to make sure that you have access to the cluster.
Sure, Frederick. I have an email right in the document that is shared right now. So.
Okay, I will take that and send it on then after after this. So if someone can add that as an action item on the agenda, that'd be great. And there was some work on the documentation that needed to be done. We got the first item out of a list of 5, almost done, documenting on what network service mesh is. And only at the high level, there are still architectural documents that need to be drafted up. So that's the current status on that. Okay, so now let's move on to the main agenda itself. So, in terms of finished work, so we've had a couple interesting developments within the network service mesh. So first, we've gotten down to a point where we're getting ready to start creating examples that make use of the data plane. So Sergey has also been working on a very simple reference data plane that we can make use of that should work in any environment. And this particular data plane is just going to be, as my understanding is, it's going to be very simple. It's not, there's not going to be any optimizations for performance or anything like that. It's just set up primarily to help us with our integration tests. So it's not meant to replace OVS or VBP or any other data plane, other than having something that is very simple. And so we've had more work done with the plugin registry. So we now have something called check deps, and I'll let Ed give a short word on check deps.
Yeah, so I've been trying to make the plugin process simpler. When you write a plugin in Network Service Mesh, you declare a bunch of dependencies so that people can wire in alternate implementations. And so one of the things I realized as I was converting the existing plugins to use this was that it's very easy when you add a new dependency to forget to either initialize and close your dependencies properly. And it's also very easy to forget to set up proper defaults for them in the mechanisms that create new instances of that plugin. And so I created a deps tool helper that basically lets you simply call, init deps or check deps, so that you can do all of that in a single call that will, when you update dependencies, then deal with the updated dependencies. So for example, if I added a dependency and I forgot to add an initialization for it, well, I can't forget to initialize it or close it now, because init deps and close deps do it for me. And if I forgot to give it a default, then I can put check deps in a test, or it gets called by init deps, for example, and it gives a very clear error that basically says, hey man, I don't know what you think you're doing, but you have a dependency that you have not marked with a tag as optional that it's not being set. And so something is wrong. I don't know what, but something is wrong. The goal being to take as much work out of the hands of the developer as we reasonably can, so they don't have to do as much work. And then the things where we literally can't figure it out, because I can't figure out what your default dependency should be, to fail as early and clearly with as clear an explanation of what to do to fix the problem as is humanly possible. Make sense?
Yes.
Cool. Okay, and so let's move on to, we have a couple documents that we've added on. So we have the Network Service Manager, or Network Service Mesh narrative slides. So Ed, I will hand it over to you, and you can discuss the slides.
Yeah, let me share those actually, and we can do as quick or short a run through as people would like.
Okay, should I stop share then, or can you stop me?
I think I can take share. Nope, you need to stop sharing because I can't take it away from you.
Okay.
Cool, thank you. Sharing Chrome. Why is Chrome not on this list? 1 second. Chrome is not on this list because it doesn't like apps in full screen. 1 second.
Ed, I can share it if you want. I got the pointers in the doc.
I can actually share it myself. One quick second. There we go. So, this is a quick narrative introduction. And effectively, the goal here was I had two things that people give me as very good feedback. One is everything is easier in a story. And the second is animation makes it very hard to read the slides, even though it can be cool for presenting them. And so, I started with a narrative. I said, okay, meet Sarah. Sarah's writing a Kubernetes app to be deployed in the public cloud. And one of the pods in Sarah's app needs secure access to her corporate intranet, right? So from Sarah's point of view, her needs look like, there's her pod. There's the corporate internet on the other side. She needs an L2 or L3 connection between them. And there needs to be some kind of security in there. But that's not really something she cares about. Right. So, and Sarah still wants her normal Kubernetes networking. That's important to her. You know, but she'd like to be able to send and receive traffic to the corporate internet. So, Sarah's definition of hell. How do I, if you were to do this in a way where you say, how do I find out subnets for an interface that connects to something? And then, who defines that subnet? And what if the subnet is too small in the future? And how do I define, do I have to define a second interface between that subnet and the VPN gateway pod? And gee, do I have to go insert routes for my corporate IPs into my pod? What if I need more replicas and the subnet is too small? What if the subnet changes? Do I have to change all the other pieces of the puzzle? What happens when the corporate enterprise guys complain that, my subnet overlaps with some subnet inside the intranet? And do I have to go redo everything? What if my network guys re-IP'd something in the intranet and now my subnet is incompatible again? Do I need a new subnet if, when they come back and say I need a firewall pod that's in line before my VPN gateway? Do I have to go back and do another subnet and do all of this work again? What happens if my corporate intranet adds kitters or prefixes? Do I have to go update all of my pods with new routes? And at this point, our little sort of, proto mascot pops up and says, maybe I can help. Who are you? I'm Adrian, the network service mesh spider. What's network service mesh? Is that like Istio? Sort of. You know all the cool things Istio does for TCP connections and HTTP. I do that for IP, Ethernet, and other L2 protocols. Tell me about your problem. I've lost my tell me about your problem slide. Apologies. I'll need to go fix that. So, this is how you do NSM. It looks like services. We point that out. So, okay, just do I need this deployment for my VPN gateway? And we sort of talk a little about the init container. No interfaces, no routes. How does all this work? Well, okay, we've got three concepts. The first is a network service. For example, secure intranet connectivity. The second is network service endpoints. It's a pod that provides the service you want. So that's sort of like endpoints for services. So is that like, the VPN gateway pod? Which it is. The third concept is the L2, L3 connection. Is that an interface? Well, usually it's instantiated as a kernel interface, but there are high-end users who want more exotic things. But you probably want a kernel interface. Okay, well, what about subnets? Well, we do these as point-to-point cross-connects, so you don't need subnets. If you want a bridge domain, that's a network service. Okay, well, what about routes? Well, generally speaking, routes for that are going to come from your network service endpoint, like your VPN gateway. You can do other more sophisticated things, but that's the normal course of events. Okay, what about new firewall pod? The new firewall pod they want to add. Well, okay, we are a mesh, and the firewall and VPN gateway pod work together to give you the network service you want, which is secure internet connectivity. And you talk about, what that looks like. So how does that work? So, virtual hosts and route rules in Istio. Yeah, so we have something similar called network service wirings. So a network service wiring has a target secure internet connectivity. That means it applies to L2 and L3 connections trying to reach that network service. It has a set of qualifiers. Qualifiers say, okay, well, if the source is not a secure internet connectivity pod, then this network service wiring applies to it. And then it has a route that connects to the network service endpoints that have label firewall equals true. So that ends up telling things that are not, so things that are not my firewall pod, like Sarah's pod, that they need to connect that way. Okay, how would you, and it sort of goes on like this, walking through question by question, the network service wiring stuff, then sort of getting to the picture here, making the point that there's no interfaces, no IPs, and no routes to be configured. Do I need a new version of Kubernetes? Do I have to use a specific CNI plugin? Well, no, network service mesh is completely orthogonal to normal Kubernetes network. It doesn't use CNI, and you can use it with your existing Kubernetes. Okay. How does it work? And we talk a little bit about, okay, well, you remember how network service mesh works? Well, we have something called the network service manager that does something similar that runs as a daemon set, with the data plane. You have your init container requesting. We sort of build out the picture this way. And we build it out sort of step by step, slide by slide, together with the story as a conversation between Sarah, the developer, and Adrian, the network service mesh spider. Make sense?
Yes.
Does this seem helpful to folks?
Yes.
Yes.
Oh, good. I was hoping it would be. Everyone likes a good story.
So fantastic. Definitely recommend people go through the presentation. So especially if you're wondering what network service mesh is about, and simultaneously, even if you consider yourself to be very well versed in what network service mesh does, go through it again and see if you can find any problems or holes or anything that pops up, unfulfilled questions that come to mind. So like even I have unfulfilled questions, and we'll often have conversations to try to work out better understanding or try to identify holes where they exist. So okay, and the last document that was added on, so the last pull request listed 183, if someone could be kind enough to share that, is a document that's going in the README that describes what network service mesh is. And I took this particular document in basically two parts. So one of them is trying to describe the problem that we're seeing. So the concept that we need more, we need better primitives that describe the type of, I guess you say, the networking intent that we want to portray, and what the whole is that we perceive within the Kubernetes community. So basically, try to establish why this particular project exists, and then the second part of this particular document is about trying to explain what network service mesh is through a series of examples. And so the example has a short prose, and it shows a sequence diagram describing each of the steps that would be taken in order to instantiate a network service mesh connection. So I just finished this up yesterday. There may be a couple grammatical errors or typos, so definitely point those out to me as well as you see them. I want to make sure that this is as readable as possible. And if you read this and there's something you don't understand at this particular point, definitely feel free to get a hold of me so we can see about expanding the document. And one of the things that I did was I stuck with the easier use cases at this particular point, because I'm worried about, like, if we go into more advanced topics as to what network service mesh can do, I'm worried about overwhelming the reader. And so those more advanced topics would still follow the same patterns, but we want to be careful as to how much we throw at a person at one time. And as that documentation gets written up, and then we'll add links to this as well, saying for further reading on the architecture, for further reading on this type of these type of network service mesh integrations. And so people will be able to find that information as it becomes available.
Yeah, and right now to get a, let me post a link as well. So because right now it's a bit weird getting a hold of it or to actually see it with while it's not merged in.
Yes, I tried that live here, and looking at the review comments isn't as interesting as actually looking at the doc itself.
Yeah, I'll pull up the actual pull review itself, and I'll point directly to it. So I'll add that as a link. So I wish this is one area where GitHub could do a bit better when it comes to documents.
Yeah, that was my problem with my own document. I added some comments, and I wanted to see how Git would render it, and it's a little hard to do that when it's like an unmerged commit.
Okay, so the trick behind this is it's whatever the branch is. So in my case, it's GitHub, fcouts, network service mesh, and then you open up the branch for the commit, and then you can then traverse to the document and see the document in its entirety through that branch. So it's not as nice as actually integrating directly into the pull request.
Oh, so you're saying go back to the branch in the GitHub account of the person that submitted the pull request, which in this case is fcouts. I see it. Okay, yeah.
Yeah, and it doesn't give you the diff though, and that's still problematic. But at least you can
see what it looks like.
And verify that the links work. Like the links are broken. If you look at the pull request view widget, the links are all broken in there, but they work when you open the branch. And they'll work when they get merged in as well. So because they're all relative to the branch. So if you click on that second link that I sent, that I stuck in there, yeah, then you can see what this particular thing looks like. And if you scroll down, we'll take a look at the first example, and you'll see what that looks like. So the first example has a little bit of prose. Then it shows the sequence diagram as to like the communication that is done between each system, and in terms of wanting a connection down to actually injecting it and getting the connection accepted message. And so I've created 5 of these examples for this particular document. Scroll down a bit and you'll see the second example is connecting 2 services. The third example is external devices. The fourth one is a bridge service, and I've stuck L2 bridge service, but it could easily be any other kind of bridge service you can imagine, the same pattern. And then scroll down a bit, and this one is the distributed bridge domain, where you hook your pods up to various bridges. And so basically building on each particular example builds up to reinforce the idea that an external device is a service. A bridge is a service. Hooking up to bridges is just requesting to be connected to yet another service. And so like really trying to emphasize that within this particular document. So anyways, if there's any questions that have come up at this particular time, I'm happy to answer. I'll give people time to read and give feedback as well. So I'll leave it at that. And with that, we've actually ran into the end of the agenda. So let's return back to agenda bashing. Is there any topics that anyone wants to discuss? Any thoughts that have come to mind?
Yeah, I added an action item for me, hopefully, to actually take like example 5 in your in Fred's document and actually implement it using VPP as a data plane and putting the code together and then documenting the steps forward. It might take more than a week, you know, but I thought that might be really useful since we're starting to talk about actually gluing stuff to data planes. So I'd do something real. Just layer 2 forwarding to start with, just to see how all the glue is going to work, and then maybe work up to something more complicated later. Kind of like your example 5.
Oh, absolutely. If you want to push that forward, by all means, it would be greatly appreciated. So there's nothing quite as good as concrete examples of something working.
Yeah, and I probably won't be the only one doing that. There's also another thing. I think it was Lucina that asked, "Is there a GitHub issue for this?" So that led me to ask a broader question: should we, for these action items, and should we have GitHub issues written for these, or are we just going to track them here with action items in the document? Just a question.
That's a good question. I'm happy with either particular direction. I think GitHub issues, we definitely want to make sure that we keep them and refer to them. I'm happy with either particular direction. So if anyone has a strong preference on one way or another, we can definitely make use of that. One thing that would be nice is if we were to use GitHub, it would be nice to have a label called action item, meeting action item or something that we can just label and use as a filter to bring up in our meetings. The only issue that I can see with it is as well with that kind of approach though is if you want to look at something historic and say what did we talk about on this particular meeting, we still have to copy them over to the document, because once someone removes that label, like the information is still technically there because GitHub says add a label at this time, remove label at this time, but trying to extract that and show it off in one place, there's no easy way that GitHub has to do that. Maybe someone can write something with the GitHub API to do so, but that sounds like a lot of work to get this particular feature. So. Yeah, so back to the example that you were talking about. You know, even showing something as simple as let's drop a new interface into a pod, like even that is very useful. Like we could drop SRIOV with that example, especially if it's one that uses the device plugin API to manage a limited number of interfaces, then that would enable us to say, yeah, this works with SRIOV, integrates with Kubernetes device plugin API, and that way that you don't oversubscribe your pods, and demonstrate, you know, even something as simple as, you know, adding a SRV or add a radio service or add you know, adding an interface. So even something like that is useful. But yeah, if you want to try to tackle number 5, you know, by all means, and you know, make sure if you run into any issues or if there's any limitations or anything you run into, you know, definitely get a hold of us.
Right.
So talking about the demonstrations, I mean, I also added a quick demonstration to the agenda bashing. So if I could have a few minutes, I could show you actually the end-to-end connectivity.
Okay, well, we have 10 minutes remaining, so the rest of the time is yours.
Thank you. All right, so let me share the screen. No, I cannot share the screen. Yeah, thank you. All right, so as Frederick mentioned earlier, I was working on a very simple data plane controller, which should allow to stitch together an SM client requesting a network service, and NSE providing that that service. At this point, it's done by using VETH interfaces, and so basically that's what I would like to show you. Right now, I don't have anything running, so this is my testbed or development cluster where I run Kubernetes. So let me start. I'm starting the NetMesh first, which is an NSM. Well, we call it. All right, so it's coming up, it's running. Now I do NSC, I start NSC, which is the service provider for that specific service. Before I go further, I'd like to show you that this NSC port has just two interfaces, loopback and the normal virtual Ethernet interface, which is provided by the Kubernetes API. Small manipulation, copy, Control-V. All right, so there are just Ethernet 0 and the loopback. So now I can start my data plane, which is running as a daemon set. And there is a gRPC server in front of the actual data plane, which is accepting gRPC requests from NSM to accomplish this connection. The server expects from the NSM just two pods with name and the namespaces, and then it goes, talks to the API, and then basically do the magic with dropping the VETH pair and then plugging in the right namespaces. So now that this one is running, and now I need to create the actual, this is the actual NSM client. So it starts, as you can see, there's a init container, it's running. Now the init portion is done, and NSM client is running. So since it's not crashing, it tells me that basically it was successfully acquired network service, and we should have a direct connectivity between NSM client and NSC. So let's do that command if config -a. As you can see, now NSC has an extra interface, and I used for the interface name portion of the name of the client. So it's going to be easier to correlate which interface used for which client. And I statically assigned the IP address it's work in progress kind of. So I just statically assign it. Now, if I want to check the connectivity, ping 1111, which is the other end on the NSM client. As you can see, I can ping through that virtual Ethernet pair. And then if I do the same for NSM client, it will also have an extra virtual Ethernet interface. Let's see. Yeah, and it has an NSC where it's plugged to, and then same thing. It has it allows end-to-end connectivity. 2 is the other end, IP address. So that's pretty much, so basically this is the kind of, now it seems like an end-to-end connectivity, and I was planning to use it in the CI. It will be very easy to test because the actual image is like a 40 meg. When I looked at the VPP, it was 3 gigs. So I thought that, pulling 3 gig from the Docker Hub would be kind of hard. So if there is something simple as this in the CI, which still tests the end-to-end connectivity, I think it's a good tool. So that concludes my presentation. If you have any questions, please go ahead.
Yeah, are you, yes, Sergey, are you, this example, is this, are you pushing this up with a pull request or something?
Yeah, there is a pull request.
Already, okay.
Yeah, yeah.
So could that be documented in the pull request number in the, or the, in the meeting notes?
Definitely I can add it. I solicited some
Thanks.
reviews like few days ago, and this morning I completed all the code, so now it's stable and it's running in the NSM. The only issue I still have is there's a dependency, and Frederick, I was hoping you could help me to sort that out, because in my local testbed build goes fine, but in Travis it's failing. So if you could help me sort that out, that would be great.
Sure, I'll take a look at it.
Yeah.
Also, the number is 181, so should be able to add that to the document.
And the second thing, while working on this example, I actually found a couple of bugs in the NetNS library, which is used to handle Linux namespaces. So I pushed 2 fixes. One got accepted and it's already merged, and there is a second one which is still in process of being merged. So if you see in the review, oh sorry, in my PR, there's a change in the vendor. It's that missing second fix, which I'm still waiting for to be merged.
Okay, I will take a look at that as well. And which would you prefer to get merged in first? Is there an order, or does it not matter?
Oh, I have only one PR.
Okay.
There's no dependency.
So
Okay, then.
I do want to. Yeah, I do want to emphasize, because this can't be emphasized enough, we have achieved cross-connect. I repeat, we achieved cross-connect. This is awesome.
Thanks.
Okay, one last note. I'm going to give the recommendation from Chris a try, and there's something called project boards in GitHub, and so I'm going to go through and open up GitHub issues for each of these items, and see if we can make use of the project board to help us organize that. So that way we don't risk having all of our information stuck in a document over time, which is still handy but not as useful. So, okay, well, thank you everyone for attending, and thank you for all of the insightful comments and information. Yeah, if there, as always, if there's any ideas or thoughts or questions that come to mind after the meeting, feel free to get a hold of us, and we're happy to help as we can. And if you'd like to join in and help out with some of the programming, again, hop in and we'll help find something that is appropriate, that meets the type of thing that you want to do. So, and with that, let's close the meeting. So, again, thank you, everyone.
Right, thanks. Thank you, everybody.
Thank you. Bye.
Bye-bye.
Thanks, bye.